The seafloor of the Gulf of Mexico is going quiet. Research boats drop cameras into water that should be crawling with shrimp and crabs, and the screens show nothing but bare gray mud. No movement, no life, just silence. We know exactly why this is happening, and we know it is getting worse. The question is not what killed the Gulf. The question is how long we can watch it die before the damage becomes permanent. The crime scene is the Gulf of Mexico itself. It sits at the bottom of North America like a giant bowl, bordered by Texas, Louisiana, Mississippi, Alabama, and Florida on one side, and Mexico on the other. For hundreds of years, this body of water has been famous for one thing above all else: food. Shrimp boats, oyster beds, fishing towns. The Gulf is not just water. It is an economic engine that feeds millions of people and supports entire coastal communities built around pulling seafood from the sea. Before we go further, we need to understand what made the Gulf special in the first place. Two traits turn this basin into one of the most productive fisheries on Earth. First, the shape. The Gulf is semi-enclosed, meaning warm water stays trapped inside, creating a perfect nursery for marine life. Second, the river. The Mississippi River pours into the Gulf every single day, carrying nutrients that act like natural fertilizer for the entire food web. These two forces working together created an ecosystem so rich that for generations the Gulf seemed endless. It was not. Here is the system we are examining: inputs, processes, outputs. The inputs are nitrogen fertilizers used on farms across the American heartland. The processes are a chain of chemical and biological reactions that happen in the water itself. The output is a massive zone on the seafloor where oxygen has been stripped away, leaving nothing alive. This is not a spill. This is not a single disaster. This is a slow, predictable suffocation driven by the way we grow food. The main causal chain is simple and undisputed. Industrial agriculture across the Midwest uses enormous amounts of nitrogen fertilizer to grow corn, soybeans, and other crops. Rain washes a portion of that fertilizer off the fields and into local streams. Those streams feed into tributaries. The tributaries all drain into the Mississippi River. The Mississippi acts like a funnel, collecting runoff from 31 states and funneling it directly into the Gulf of Mexico. Once that nitrogen-rich water reaches the Gulf, it triggers a biological chain reaction that ends in death. Let's start with the first piece of evidence. The Gulf was once a shrimp factory. Boats would go out and come back loaded. The mechanism behind this abundance was straightforward. Warm water plus steady nutrients from the river created ideal conditions for shrimp to grow and reproduce. The seafloor was covered in small creatures, worms, crabs, tiny invertebrates, all of which fed the shrimp population. But now we see the loss. The same nutrient system that fed the Gulf is now killing it. The nitrogen overload has turned the seafloor into a graveyard. Shrimp boats return to port with catches so small that some fishermen have stopped going out altogether. That is the reality check. The boats do not lie. Now for the second piece of evidence. People who live along the coast sometimes see the water turn green. Not the clear blue-green of healthy ocean water, a thick, soupy, unnatural green. The mechanism here is algae. Nitrogen acts like a steroid for microscopic algae floating in the water. When nitrogen floods in from the river, these algae multiply at an explosive rate. Scientists call this a bloom. From space, satellites can see a massive green plume spreading out from the mouth of the Mississippi, covering thousands of square miles of ocean. That is the wow. Here is the loss. When the algae die, they sink to the bottom. Bacteria in the water break them down, and that decomposition process consumes oxygen. Vast amounts of oxygen. The water becomes hypoxic, meaning there is not enough oxygen left for fish, crabs, shrimp, or anything else that needs to breathe. The check is visible from orbit. Satellite images show the plume. It is not subtle. The third piece of evidence comes from the seafloor itself. Normally, the bottom of the Gulf should be alive. Worms burrowing in the mud, crabs scuttling across the sand, small fish darting between rocks. This activity is the foundation of the entire food web. Larger fish eat the smaller creatures, shrimp feed on the organic matter, everything is connected. But in the dead zone, there is nothing. Researchers send down remotely operated vehicles with cameras attached, and the footage shows a barren wasteland. No movement, no color, just empty mud. The mechanism is oxygen. Marine life needs it to survive. The loss is total. Anything that cannot swim away fast enough dies. The proof is in the footage. The seafloor is dead. If you are following this breakdown, consider subscribing. We are building a library of these forensic investigations into ecosystems under pressure, and each one follows the same method: verdict, mechanism, loss, proof. No guessing, no moralizing, just the chain of cause and effect. There is also an accelerator making everything worse. Climate change is raising water temperatures in the Gulf. Warmer water holds less oxygen than cold water. That is basic chemistry. So even before the algae blooms start consuming oxygen, the water is already depleted. On top of that, climate change is altering rainfall patterns. More extreme storms mean more rain in shorter bursts, which means more fertilizer gets washed off fields and into the river all at once. The two forces work together. Higher temperatures reduce oxygen capacity. Heavier rains increase nitrogen load. The dead zone expands. The cascade of consequences follows a clear path. First, the seafloor ecosystem collapses. The worms, the crabs, the small invertebrates all die off. Second, the species that depend on them for food disappear. Shrimp populations crash. Bottom-dwelling fish move away or die. Third, the commercial fisheries that depend on those species face economic collapse. Boats sit idle. Processing plants close. Fourth, the coastal towns that have built their entire identity around fishing face a slow, grinding economic decline. Jobs vanish. Families leave. The culture erodes. This is not speculation. This is the logical progression of a system losing its foundation. This is not a story about a single event. It is about the loss of a function. The Gulf is losing its ability to produce food. The fishing industry is losing its resource base. Coastal communities are losing their economic engine. The expectation that you can go to a restaurant and order fresh Gulf shrimp is tied directly to the oxygen content of the water miles offshore. When that oxygen disappears, everything built on top of it starts to crack. The trajectory is sobering. The Mississippi River/Gulf of Mexico Hypoxia Task Force, a coalition of federal and state agencies, set a goal back in 2008. They wanted to reduce the 5-year average size of the dead zone to fewer than 1,900 square miles by 2035. That was the target. As of 2025, the 5-year average stands at 4,755 square miles. That is more than 2.5 times larger than the goal. The dead zone is not shrinking. It is holding steady at a catastrophic size. In summer 2025, the measured dead zone was 4,402 square miles. That was actually the 15th smallest measurement in 39 years of monitoring, but the 5-year average tells the real story. Without major changes to agricultural practices, the dead zone will persist. It may grow. To track the progression of this case, we monitor 3 signals. First, the square mileage of the hypoxic zone. Every summer, scientists funded by NOAA board research vessels and measure the size of the area where oxygen levels drop below 2 milligrams per liter. That number tells us the scale of the crime scene. Second, the nitrogen load in the Mississippi River. This is measured at monitoring stations along the river. It tells us how much fuel is being pumped into the system at the source. Third, commercial shrimp landing statistics. These are collected by state agencies and the National Marine Fisheries Service. They tell us the economic impact in real time. When shrimp landings drop, we know the ecosystem is failing. When they stabilize, we know something is working. Right now, they are not stabilizing. In the final analysis, the Gulf of Mexico is not being poisoned in the traditional sense. It is being choked by abundance. The same nitrogen that makes Midwestern fields so productive is suffocating the sea. We engineered a system to grow more food, and that system is killing one of the most productive fisheries on the planet. The irony is brutal. The fertilizer that feeds us is starving the Gulf. This forensic breakdown of the Gulf raises a new question. We have examined a case of suffocation driven by agricultural runoff and accelerated by climate change. Should our next investigation focus on an ocean turning acidic? Or a wetland drained to make way for cities? Drop your vote in the comments. Thanks for watching. If this breakdown changed the way you see the Gulf, hit subscribe. We will keep following the evidence.